Welcome to the story of the element girl silicon from family 14 or the carbon family with atomic number 14. What would we do without technology these days? Dad remarked, observing the bustling coffee shop on Saturday morning. Everyone was engrossed in their smartphones, tablets, or laptops. Laughing, Dad added, "Is there anything a silicon chip cannot do?" Inspired, I exclaimed, "That's it. It's time to visit Silicon." I messaged my friends to see who was interested in visiting Silicon. Within an hour, Valence and Albert responded enthusiastically. That afternoon, we gathered at Albert's uncle's electronics store. We set up the periodic table on a picnic table under a tree in the store's backyard and pressed the symbol SI for Silicon. As the trees and blue sky swirled around us, we cried out in delight. In an instant, we found ourselves on a golden sandy beach, surrounded by the sight and sound of ocean waves and a few seagulls fluttering overhead. We removed our shoes and spent a few minutes wading through the knee-deep water as the waves washed over us like thick foam. The water was pleasantly warm, and we savored the feel of the sand and sea on our feet. We heard voices from the far end of the beach, and Albert shouted, "Silicon is over there." We saw a small group of people gathered around someone who seemed to be juggling various objects. As we got closer, we realized it was a girl juggling a laptop, a tablet, a smartphone, and a smartwatch. She wore bluish-gray shorts and a matching top, both adorned with what looked like computer chips. Her outfit included a tutu made of computer chips as well, perfectly suited for the warm beachside weather. Her stylish shoes, also bluish-gray with short heels and straps running up to her mid-calf, seemed impractical for walking on the beach, but they added a unique touch to her ensemble. Once her juggling act finished, the crowd erupted in cheers before gradually dispersing. She tucked the devices into her backpack, which she placed under an umbrella on a large beach towel. Then she looked up with a big smile. "Welcome to this sandy beach. I'm Silicon." She greeted us, her eyes sparkling. She then removed her shoes and began wading into the water. We eagerly followed, enjoying the refreshing sensation of the waves on our feet. Silicon asked, "Do you know why I'm meeting you on a beach?" Still wading in the water, I exclaimed, "Sand is silica, silicon dioxide. While oxygen is the most abundant element in the Earth's crust, you are the second most abundant." Silicon applauded. "Excellent. Yes, I make up about 28% of the Earth's crust, and I am the eighth most abundant element in the universe." Then Albert chimed in. "Since silicon is in sand, it makes sense to meet you on a sandy beach. I had guessed we might meet you in a semiconductor manufacturing facility or a computer store." Silicon responded, "Absolutely. In the electronics industry, I am essential for manufacturing semiconductor chips. Silicon is crucial in making diodes and transistors, which are fundamental components of electronic circuits. Diodes allow current to flow in one direction only, making them vital for power rectification, which is the process of converting alternating current or AC into direct current DC, so they can be used in chargers for devices. Transistors amplify or switch electronic signals, serving as the building blocks for processors and memory chips. These chips are the brains behind all the electronic devices we use today, like computers, tablets, smartphones, audiovisual equipment, medical devices. The list goes on. Can anyone tell me why silicon is ideal for the semiconductor industry?" Valence answered, "Silicon is a metalloid. Metalloids conduct electricity better than nonmetals, but not as much as metals, making them perfect for the semiconductor industry." Silicon said, "Excellent. Anything else you can tell me about silicon?" I replied, "I have some baking equipment made of something called silicone with an E at the end. That contains silicon, right? Silicon nodded and explained. Silicone is a long chain polymer made up of silicon and oxygen atoms bonded with carbon and hydrogen. These polymer chains can form rubbery solids, liquids, oils, and pastes. Silicone can withstand a wide range of temperatures, typically from about negative 68 degrees C to 230 degrees C. This makes it ideal for various applications like kitchen gadgets, as it remains stable and retains its properties in both extreme cold and high heat. Silicone-coated materials are water repellent, making them perfect for use as sealants around bathtubs and sinks, and for equipment used in water sports. Soon, the breeze on the beach began to pick up, causing Valence's unruly hair to tangle and cover her face. Laughing, she said, "My mom always tells me to use silicone hair products to tame my hair. How does that work?" Silicon answered, "Silicone products for hair coat the hair strands with a thin protective layer. This layer smooths the cuticle, reducing frizz and adding shine. Silicones also provide a barrier against moisture and heat, helping to protect the hair from humidity and thermal damage from styling tools. They can make hair feel softer, shinier, and easier to manage." For a while, we simply listened to the sound of the breeze and the waves crashing on the sandy beach. As the water receded, we noticed some foam left behind. Pointing to it, Silicon explained, "That foam contains countless single-celled algae called diatoms, whose cell walls are made of transparent silica or silicon dioxide. It is like these algae are living in glass houses. They absorb the sun's energy and carbon dioxide, producing glucose through photosynthesis. Diatoms are a significant part of the phytoplankton and play a crucial role in the marine food chain." We stood on the beach near the foam, marveling at the idea of tiny diatoms surrounded by glass-like walls. Valence asked, "Can you tell us about some more of your applications?" Pointing to my quartz watch, Silicon responded, "The quartz in that watch comes from sand and is crystalline silica, or silicon dioxide. When subjected to mechanical stress, the crystal deforms and generates an electrical voltage. This phenomenon is known as the Piezoelectric effect, discovered in 1880 by the French scientist Jacques Curie, 1855 to 1941, and his younger brother Pierre Curie, 1859 to 1906. Piezo means to press in Greek. Here, mechanical energy is converted to electrical energy. Conversely, if you apply an electrical voltage to a quartz crystal, it vibrates, which is the inverse piezoelectric effect. Here, electrical energy is converted to mechanical energy. In a watch, when electricity from a battery is applied to a quartz crystal, it vibrates at a precise frequency, 32,768 times per second. The quartz crystal acts as an oscillator, since it vibrates constantly, creating a stable and accurate timekeeping signal useful for watches and electronic circuits. The semiconductor circuit in the watch counts these vibrations and generates electrical pulses every second. These pulses can either illuminate the time display on a digital watch or power a tiny electric motor that moves the hands on an analog watch through a series of gears. I exclaimed, "A small quartz crystal powering all that? Amazing." Silicon smiled and then switched to a serious tone. "Thank you. Quartz is a common mineral found in sand. However, silica dust found in places like construction sites poses serious health hazards. It is classified as a carcinogen, capable of causing lung cancer. Exposure can also lead to silicosis, a condition of irreversible lung damage, and other respiratory issues. It is crucial to be aware of these dangers and to implement strict safety precautions in environments where silica dust exposure is possible. It was quite warm by then, so I took out my glass water bottle and took a sip. Silicon then asked, "Can you tell me something about glass and silicon dioxide?" I responded, "Glass is produced by melting sand, which is primarily silicon dioxide." Silicon nodded in agreement and said, "Glass making involves heating a mixture of sand, soda ash, and limestone to high temperatures. The silicon dioxide in the sand melts and combines with the other ingredients to form molten glass, which can then be shaped and cooled to produce various glass products." As we watched the sunset, Valence asked, "What about Silicon Valley? Isn't that connected to silicon?" Silicon smiled warmly. "Indeed, it is. Silicon Valley, located in California, is renowned as a global center for technology and innovation. Vast number of semiconductor and computer-related companies were established there during the mid-20th century. The region's association with silicon comes from the pivotal role of silicon semiconductors in the electronics industry, which revolutionized computing and technology. The discovery of silicon itself dates back to 1824, when Jöns Jacob Berzelius, 1779 to 1848, a Swedish chemist, first prepared silicon in a nearly pure form by reacting potassium fluorosilicate K2SiF6 with potassium metal. This breakthrough laid the foundation for the widespread industrial use of silicon, particularly in electronics. We helped Silicon pack her umbrella and towel as the sun dipped below the horizon, casting a golden glow over the beach. With heartfelt thanks and a wave of goodbye, we found ourselves back in Albert's uncle's electronics store backyard in an instant. Soon we hopped on our bikes and rode home, exchanging farewells along the way. The aroma of baking pizza greeted me in the kitchen, where Dad expertly used silicone oven mitts and pot holders to handle the hot pizza. Mom arranged silicone placemats on the dining table. Sitting down to eat, I said, "Mom, Dad, let me tell you all about silicone versus silicon." Over a delightful homemade veggie pizza, I recounted everything I had learned about silicon that day. Even Electron, my dog, sat close by, attentively listening and savoring the occasional pizza crumb. There you have it, the story of silicon. From the magical periodic table and the Element Girl series, Book 6, Family 14, The Carbon Family. Happy learning. Thank you.